Venn diagrams versus two-way tables. We're going to look at the relationship between Venn diagrams, two-way tables and probability. That's our goal for this video. We can see we have an example here, and the example written here says for each diagram, well, I've only got one diagram here, so for this diagram find the following probabilities. We've got three things to find: the probability of A intersection B, the probability of A in union with B, and the probability of A complement, or in other words, the probability of not A. What we'll do is we'll sketch a Venn diagram nearby just to show the relationship. You don't necessarily need to sketch the Venn diagram, but because we're used to those, we might begin by doing that. It'll make things a bit easier to connect. And in maths, it's good when we can connect our ideas together with what we already know. So that's our structure for the Venn diagram. Next, we can look at the two-way table. Now, a two-way table has two quantities or two different things, one plotted along the columns and one put along the rows. And we can see we've got some numbers given to us already. And look at row B, we see that something plus 8 equals 13. That would mean that that's 5. And if we go down this column here, 5 plus 4 would make a total of 9. In the A complement column in the middle, we've got 8 plus something equals 12. That would be 4. Going across, not B, or B complement, we've got 4 plus 4 would give a total of 8. Now, a good way of checking both of these totals downwards and also to the right should equal the same thing. 9 and 12 is 21. 13 and 8 is also equal to 21, so that's a good sign. So we've got a sample space with, or a universal set with 21 elements in it in total. That's what that grand total means. Now, one thing I'd like for us to do is to be able to relate the numbers in the table with the numbers that will end up in the Venn diagram. So we've got an intersection here. We'll call that one set A and that one set B, like we often do. And A intersection B will go in the middle, as you know, and A intersection B is basically this number here. You see A and B where the rows and columns match, and that means that it will be 5. And what we can do is fill out the rest. Now, we need stuff to go into this part of the Venn diagram here that fits in there. What that is stuff in A but not in B. So we look for stuff that's in A, which might be in that column, and not in B, which should be 4. So we can see that the 4 will go here because it's in A but it's not in B. So we need to look at now what's going to go in here, and again that's in B but it's not in A. So we look at what's in B but not in A, and we can see that that would be corresponding with 8. So we can put 8 in there. Okay, we have a sample space or a universal set with 21 elements in it we just saw, and we know from our work in Venn diagrams that everything in that rectangle must add to 21. Let's look at what we've got now. We've got 4 plus 5 plus 8, so that's 17, and another 4 makes 21. We're definitely ready now to answer the questions. So the three questions again were written, as you can see there. The first one is the probability of A intersection B. So let's address those now. If you do a bit of thinking and reasoning, the questions will come out more easily. So the probability of A intersection B, whether we look at the table or look at the Venn diagrams, it's pretty easy now. The Venn diagrams is very easy. We've got 5 in the shared zone there. Okay, and let me just make that nice and clear for you. As you know, that's it there. Where does that exist on the table? If you don't want to get it from a diagram, you can get it from there. So we've got a 5, but it's a probability, remember, so it's not just the number, it's 5 out of the total. And remember, the total is 21, we saw there, because the sample space is the total number of outcomes. We can't simplify that any further. A union B, so probability can just be P or PR, it doesn't matter. So A union B, now remember when we were dealing with Venn diagrams, A in union with B was all of that together, 4, 5 and 8. So where we see that here is 4, 5 and 8 like that. Okay, it's those ones there. Now when you think about it, it is those ones because we've got the shared zone in the middle. We've got in B but not in A, which is that or that, and we've got A but not in B, which is that, in other words that, and that's what union means. It's all of that straight across. So let's have a look. We've got 3 numbers to add together. We've got 4 plus 5 plus 8. Alright, and that's 9 and 8, and that's 17. And the total is 21. So it's 17 21st. We can't simplify that. Last one is probability of not A. Alright, so we need to look at what that means. So obviously not A can't be anywhere in the influence of this circle. It's got to be purely outside of this circle in the Venn diagram. So it can't be the 4 and the 5. It's everything outside. Now that includes a few things there. It includes the 8. That's outside, and includes the 4. So that's all that we need to do is 8 plus 4. Okay, and we go 8 plus 4. We could do that bit in your head, I suppose, over the total of 21, which is 12 over 21, 12 over 21, and 12 over 21 we can divide top and bottom by 3, so we get 4 over 7. Another way of looking at that is in the 2A table is adding up the not A column, which is actually easier. That not A column, everything in there adds to be 12 out of a total of 21, which you can see over here we had 12 over 21 there. So sometimes tables have advantages. Let's try some.